Okay, hi everyone. I'm Dr. Furness. I'm one of the teaching faculty here at School of Mines, and I am also the lab director this semester. So what I've decided to do is record this video to go over the blue dye lab calculations for the result sheet. That way you all can take your time and go through this video. You can watch it at your own pace. You can pause, you can go back. This is just to hopefully help you get through the calculations. I'm going to go through it step by step using Excel and show you how to fill it out on the result sheet itself. So hopefully this can answer any questions that you have. So let me just go ahead and share my screen. Okay, so here is the result sheet that you will be filling out and that you need to submit. So if you see here, what I did, let me actually get out of this so you can see this. You can actually, if you have Preview or some sort of PDF editor, you're able to edit the document directly on it. So that way you don't have to print this out and handwrite everything. Highly recommend doing this if at all possible, just because it makes it a lot easier for the graders to be able to read your handwriting, or I guess it eliminates the need to be able to read your handwriting. And so if you look right here, this box is the autofill box. And the way that we have this set up is that it will then go toggle from each of the different boxes where you can then fill out your information. So right now I have it highlighted. And so if you see here, right, it'll go through, right, you can type in all of your different info. So please make sure that you're using your actual lab section. If you're not sure what lab section you're in, this is posted on Canvas under modules, general course resources. There's your TA contact info. On that same document, you'll also find your lab section. So please make sure that you're including that, because if you don't include this info, you will lose points. Right, then we'll go and fill out the initial stock concentration. So this is what you should have written down. This may have been different between week 1 and week 2. Your TA probably wrote this on the board, but this was on the bottle that was in the hood. I am making these numbers up, so please do not use the numbers that I am using. I'm just doing an example, so this value will be different depending on what section you were in, okay? If you don't have this value, you might need to reach out to your TA to see if they happened to write it down for you. Okay, then we're gonna go down to, so if I hit the tab, we'll go down and we'll get the volume of the stock blue dye that you added to each of these flasks. So it should have been that you added 0 milliliters, oops, and then we can go down to the next. You added 2.00. We added 5.00. Notice I'm using 2 decimal points behind this because the volumetric pipettes should have 2 decimal points of accuracy on them. Then we have 10.00, 15.00, and 20.00. Okay, again, this is just one way that you can edit this document. Like I said, there's also absolutely nothing wrong with printing out a copy and filling it out. I will say this, some students will generate their own version of this. As long as it looks almost identical to what is presented, I will accept that as well. But it can't be a situation where I'm having to search for information, okay? There are somewhere between 350 and 850, depending on the semester of these, that need to get graded. So if the grader needs to be searching for your information, you will lose points, okay? All right, the other piece of information that you should have obtained while you were doing this experiment are the absorbance values. So again, please do not use my absorbance values. There's a chance yours might match mine, but if they don't, make sure that you're using the actual absorbance values that you got, okay? And so then I have 0.223. So these are the values that the UV vis or the spectrophotometer, I guess, recorded when you were analyzing your samples. And 0.674, and the last one 0.896. Again, these are just the example ones that I have. Okay, so at the end of the lab, you should be able to at least have this much set up. And then once we do the calibration curve, then I'll go ahead and scroll down and we'll go through the unknowns as well. But I'm going to do the data analysis and the calculation using Excel. You can use whatever graphical software program you would like. I just personally am most familiar with Excel, but if you prefer Google Sheets or Cells or Desmos, I don't care. It doesn't matter, just so long as you are able to get all of the required information. Okay, so now I'll stop sharing that screen and let's move this over and share again. Okay, so if you see here, this is the Excel spreadsheet that I set up. You don't have to make yours look as fancy as I did with mine, but what I liked to do is just set up the spreadsheet the exact same way as the result sheet itself. It just makes it a little bit clearer for me. Okay, so if you see here, I have all of my blank solutions with their titles. This is the volume of the stock solution that I had. If I toggle back over here, you'll see, right, this is the volume of the stock solution. We're going to use Excel to calculate this column here. All right, and then I have the absorbance values. So let me just type these over here. So I have 0, 0.087, 0.223, 0.441, and 0. Okay, so now I have my absorbance values. All right, to determine the concentration of the blue dye lab, if we think about this from a chemical perspective, what did we do? We took a stock concentration, we took a specific volume of that, and we diluted it to a new volume. So this should be a dilution problem. Dilution problems, if we remember, we use M1V1 equals M2V2 or C1V1 equals C2V2, depending on how your instructor presented it to you. So I teach it as M1V1 equals M2V2. All right, in this case, our M1 is going to be our initial concentration. So for mine, my initial concentration is this stock concentration, 0.0667. All right, my V1 is going to be whatever's in this column here. All right, and then my V2 was the 200 milliliters because every time I diluted to the 200 milliliters in those volumetric flasks. And what I'm solving for then is M1. So if I like to use Excel to plug in these formulas. So you can click on the cell and then you can type the formula up here in the top. And so we're going to say M1. Okay, so I'm going to do some parentheses. My M1 was 0.0667. Let me just make sure that's what it actually was. 667, yes, okay. Times V1. So for my V1, because this is changing, rather than having to type this formula out every time, I'm going to show you a shortcut. We can click on this cell and it's going to highlight that. Okay, so that's my V1. All right, all of that then divided by my V2. So my V2 was always 200, so I can leave it as 200, and then I'll hit enter. Oops, get rid of that guy. All right, and so this would make sense then that the initial concentration, or excuse me, the VM2, so the final concentration for this first sample or my blank is going to be a 0. Then what I can do to make my life easy is this little green square in the corner here. If I highlight this and now I have this black plus, if I double click, it will now calculate the concentration of these dilute samples for me. All right. So, and if you highlight any of these cells, you'll see up at the top here that the formula is changing to account for this specific volume that was added. All right. So now I have my my concentrations of my blue dye. This would be the concentration that I had in each of the individual 200 milliliter volumetric flasks. All right. And so then again, I can transfer that over here, which for sake of time, I won't do that right now, but right, I can go ahead and plug in all of those values. Actually, I guess I'll just do it quick. So we have 0, 0.123667. Make sure you're including all of these 0.0s that are there. 003335, 0.00. Okay, and actually I'm catching myself doing this. All right, the first question is going to be how many sig figs should I have here? So if I look, my stock concentration had 3 sig figs. All right, All of these have 3 or 4 sig figs, all right? And then my volumetric flask would have, so it was 200 with 2 decimal places, which means it would have 5 sig figs. So between 3, 4, and 5, 3 is going to be the smallest number, which means all of my concentrations here should also have 3 sig figs. All right, so this one has 3, so this one I need to change this to 0.00. I don't know where I got that 3. 167. This one should be 0.00334. 0.005. Okay, so this one's kind of tricky, right? But this time I would keep those 2 zeros, right? Because if I look, I need to have 3 sig figs. Remember, the 2 or these 3 zeros leading out front are just placeholders, because if I put this in scientific notation, they would go away. So that means I would need to include these 2 zeros because I have a 2. That 0 does not round up, so it stays as a 0. So I would need to report it like this. All right, and then my last one is going to be 0.00667. Okay. So now I have my concentrations filled in. Like I said, these should all have 3 sig figs because our stock concentration had 3 sig figs. All right, I'll go back to Excel. Now what I need to do is I need to get an equation of the line, or this would be considered our calibration curve or our standard curve. So to do this, again, I'm going to use Excel. And so what I can do is I can highlight these here, and then I'm going to go up to Insert. All right, and on mine here, I'm looking at these different charts. And so this chart is a scatter plot. So I'm going to do scatter plot and then this one. So I don't want the points connected because I'm wanting to create a best fit line. So I'll select the scatter plot and boom, there is my chart. I believe that this chart is required to be included in either your post lab for blue dye part 1 or blue dye lab part 2. I can't remember. All right, so I have my absorbance values on the y-axis and I have my concentration values on the x-axis. All right, it looks pretty straight, but let's do a little bit of math or include a few things. So what I can do is I can highlight the data, and then over here I will go to add chart element. All right, depending on your version of Excel, or if you're doing this on the online version, there may be a different location to find to add these elements. So Google it maybe, right, to figure this out. But for me, because I'm using the desktop version, I go over add chart element and then I'll do trend line, and we want linear, right? And so then now I have my linear trend line. If I double click on my trend line, it'll pop up some of these options over here. All right, I want the linear trend line, and then 2 things that I want to include are display equation on the chart and display the r-squared value. All right, so remember the r-squared value tells us basically how good our precision was. All right, and so here my r-squared value is 0.99999, which is really good. Anything above 0.98 is considered a linear curve, okay? If you're looking at this and your r-squared value is lower than 0.98, you may already want to consider redoing the calculation or redoing the blue dye lab. And then here I have my equation of the line, y equals mx plus b, where y is going to be my absorbance value and x is going to be my concentration. If your equation of the line should be on this order of magnitude, okay? Again, it's not going to be exactly 134 as your slope, but it should be somewhere in that range. If you're getting a slope that's like 4 instead of 134, or if you're getting a slope that's like 10 million, there's an issue, all right? So double check that. This is a good way to check to see if this is working. So then I'm just going to transcribe this over here and say y equals, okay, or we could, I mean, be a little fancier and say absorbance equals 134.57 times concentration plus, okay, which is really in this case minus because I have a slightly negative y-intercept 0.0021. Okay, this is now the formula or the equation that I'm going to use to calculate my unknown sample. Excuse me. One other thing that I can mention here is if you want to display the correct number of sig figs on your Excel spreadsheet, you can highlight all of these. So all of these volumes should have 2 decimal places behind it because all of the volumetric pipettes, right, have an accuracy level to the hundredths place. I can then go up here. So underneath this kind of number, all right, this with the arrow pointing left will increase the number of decimals. So if I click this twice, now all of my volumes have the correct number of sig figs. Same thing here. If I want this to have 3 sig figs, I can then get rid of some of these and change it. I guess this might be a little different. It's not going to work for this one because of this guy right here. So you can leave it as is and just make sure that you round it correctly, but it could help you with the rounding if that helps, right? So if we look at this one, this was the one that was kind of funky. If I have 3 decimal points after that, that's showing me that those 2 extra decimal points would both be zeros. Okay, that was a mini side note. We can do the same thing for this just to make it look consistent. Okay, and so now my absorbance values are going to be, now I'm going to calculate the concentration of my unknown. And so for my unknown, if we're thinking through this process, essentially your unknown, the sample that you got in your specimen vial that had the code on it, that's more or less the equivalent of the stock that you got out of the hood. Okay, so think about it that same way, right? But this time we don't know what the stock is. So in this case, we're technically looking for M1, right? So if we think, right, M1 V1 equals M2 V2, this time we're going to be able to do some math to figure out what M2 is. We know what our 2 volumes are, and then we're going to be back calculating to figure out what the original stock concentration was in that sample vial. All right, so my absorbance values for my unknown. So again, these would be the unknown. So I take 20 milliliters of each of my unknown samples, and let's say that I get 0.0, not 0.0, 0.578, 0.577, and 0.579. Okay. Again, I just made these numbers up. Please make sure that you're using your own absorbance values. All right, this may be the trickiest part right here, is to calculate the concentration of the blue dye. I'm calculating the concentration of the blue dye that would be in the 200 milliliter volumetrics, all right? So to do this, I use my equation of the best fit line, right? Or I use my equation for my calibration curve. Again, you can do the same type of setup where we put the formula into this cell, so that way it'll automatically calculate it for us and we don't have to do it every time. All right, so this time I'm solving for concentration, right? I know the absorbance values. I found them using the UV Viz, and so I'm trying to solve for X. So if I rearrange this mathematically, or I guess algebraically, we would get our absorbance value, which is this one here, okay, minus, well, so because I have a negative B, I would then be adding, so plus my y-intercept, 0.0021, okay? And then to solve for concentration, I'm gonna have to divide both sides by the slope. So all of that then divided by my slope of 134.57, okay, equals this, okay? So this would be the calculated concentration for the blue dye that would be in the diluted volumetric flasks, okay? And so I can do the same trick that I did up here for these concentrations. I can double click this, or you could drag it down, all right? And now it's calculating the concentrations for each of these different absorbance values. And like I said, you can click on the individual cells and see that it is in fact taking the various absorbance values, okay? Our dilution factor, because I took 20 milliliters and I diluted it to 200, this is gonna be a 10, right? Dilution factor of 10, all right? Which means then my original sample is going to be 10 times more concentrated than the measured sample, right? This should make sense. So then to calculate the original, I can do the same thing where I'll say equals, right? And then I'm gonna take the original sample times the 10x dilution factor, and this would be the concentration in my unknown vial. All right, this is the concentration that I'm trying to report. All right. We can then calculate the average. So if we say equals and then AVG, so you just start typing in, right? Sorry, AVE. Start typing in average, and then I can highlight these three numbers here, parentheses, enter. This would be my average concentration of my unknown sample. So let's get out of this. All right, and we can go back to my result sheet here. Right, so we need to include the equation of the line here. If it won't let you include it, you can double click on that location, or you can always create a text box, which is right here. All right, and that will let you fill this in. So I have absorbance. You could leave this as y equals mx plus b if you want, or you can change it to the absorbance and concentration. Either is correct, okay? In the packet, I tell you that you should report this to 3 sig figs because our concentration of our stock was 3 sig figs, and most of our absorbances were also 3 sig figs, okay? So let's go ahead and report this to 3 sig figs, which makes this 135, okay, times concentration. Like I said, you could leave it as X if you prefer, minus my y-intercept 0.0021, and I'm just going to make this box a little bit wider so that way it fits on the line nicely like that. Okay, that's what we're looking for here. Again, I guess this slope should also technically have 3 sig figs, so we want to add 1 additional 0 on the end here. All right, so for your equation of the line, the slope and the y-intercept should both have 3 sig figs. All right, make sure that you have it like that. All right, now that Excel did all of this for us, we can just go ahead and type our values in. So this is going to be our 20. Oops. Maybe it won't do it. Okay, let's try again. Not letting me type it in. Okay, so for this part, just again for sake of time, and I'm not going to try and troubleshoot it, you might need to create individual text boxes if you're going to edit it like this. I don't know why, for some reason it's not letting me do that, but you could also do markup. I'm going to try one more thing, and then if it doesn't, I will move on. Yeah, so you could always create a text box like this, which might take a little bit more time, okay, than it was taking on the top. But this is going to be 20.00, okay? And then you can just copy this. So we'll do copy, paste, slide it down here, paste, slide it down here, right? Because those were all the same. We can then do our absorbance value. So my absorbance value was 0.578. Okay, and then we'll do the same thing. We'll do copy, paste, paste, and we'll slide these. So again, you can adjust this. Like I said, you could always print this out and do it by hand. I don't have a preference as long as I am able to read your handwriting. And we said this one was 9. Okay, we'll add another text box for this. And so our concentration, again, now our calculated concentration in Excel is going to be given to us with all of these decimal points. We want to make sure that we round it to 3 sig figs. Okay, 0.00431. This first one, and that one goes up here. Okay, we'll copy, paste, paste these down here. Okay, this one is 4303. So 4303. That's too many. So that would be 430. Right, and then the last one is 43, and then this one would round to 2. 432. Okay, and we can make this wider. All right, all of these have 3 sig figs now. All right, dilution factor here is going to be 10. So 10, and then we can do the same thing where we do copy, paste, paste. 10, 10, 10. Okay, and then the concentration of this dye, so I'm just going to copy this guy, copy, paste over here. So this is going to be just 10x more concentrated, so we can get rid of this 1, 0. You can do the same thing here, copy, paste, slide it over, get rid of my 1, 0, and then copy, paste, and get rid of my 1, 0. Okay, all right. I have discussed all of these with you, so I'm not going to go through them. That way you actually have to think through it a little bit. Like I said, the one that I did tell you explicitly is that the equation of the line, the slope has to be 3. So that's the only one that I think there may be some confusion on. All of the rest of them, I have discussed them throughout this video. All right, for our unknown code, right, that would be our CH and then whatever those 4 numbers are. Again, make sure that you include this. If you don't include it, automatic 10% deduction. All right, and then our average concentration. So my average concentration for my blue dye sample was 431. Okay, so we'll say 0.0431. Again, reporting to 3 sig figs. All right. And that's it. So like I said, you don't need to include the graph in the actual result sheet, just all of the things that we went over and that we discussed. You do remember still have a post-lab questions that you need to answer, including your lab notebook pages as well. So I hope this video helped. Like I said, you can do this in any graphical software that you prefer. But I just went over it in Excel. I know Excel is also part of the free software from mine, so you should all be able to access that. In any case, if you have any additional questions or things that didn't make sense, please do not hesitate to come to my office hours, go to your TA office hours, email me. You can go to any of the lab profs office hours. We're all here and available to help you. So, all right, I hope that helped and good luck. Hopefully your accuracy is great. All right, bye.